Hello students, welcome to my chemistry channel. So students, in the last video lecture we have seen about the SN2 reaction, nucleophilic substitution reaction we have seen there in detail. So in the today's video lecture I came with a new topic, that is a new name reaction, that is a cannizaro reaction. So students, already we have discussed the aldol condensation. So if you remember that aldol condensation, the previous video lecture of mine, you can easily correlate with this cannizaro reaction. So this cannizaro reaction, basically it is a base catalyzed or the base induced disproportionation reaction in which the two molecules of aldehydes without having the alpha hydrogen gives primary alcohol and the carboxylic acid. So students, I just want to take you in the back that when we were discussing about the aldol condensation, there we have seen that the substrate we have used there. This is for your easy understanding. You can easily correlate with the aldol condensation. That what is the difference between the two, right? So there we have used what? Aldehyde or the ketones, right? We have used as a catalyst. We have used what? Dilute base or dilute alkali, right? Now here in this cannizaro reaction, the substrate remains the same. We will not use a ketone. We will use what? Aldehyde. Okay, and that aldehyde in the aldol condensation, we have used those aldehyde in the ketones which contain alpha hydrogen, right? At least one alpha hydrogen must be there in aldol condensation. But here in cannizaro reaction, we do not require any alpha hydrogen. So we have to choose what? Aldehyde. The two aldehyde may be the same aldehyde. You can take different aldehydes. Okay. But those aldehyde what you will choose, that should not contain the alpha hydrogen. Okay. But in aldol we have chosen the aldehyde or the ketone which contains the alpha hydrogen. This is the difference between the two. There the catalyst what you have used, that the reaction was taking place in the presence of dilute base or the dilute alkali. We have taken dilute NaOH, dilute KOH, right? But here in cannizaro reaction, we will use what? Strong base, okay? Or you can say the concentrated alkali or the concentrated, we can use NaOH, we can use concentrated KOH, okay? There we don't have that disproportionation reaction. But here this is a disproportionation reaction. Disproportionation reaction means what? Means the aldehyde, the 2 moles of aldehyde which you will take, one of the aldehyde will get oxidized and the other one, the aldehyde, that will get reduced. Means the two same molecule. One molecule will get oxidized and the other molecule will get reduced. Okay, that is the meaning of what? Disproportionation reaction. Okay, means the same molecule will oxidize and reduce simultaneously. Okay, and this reaction is taking place in the presence of what? That is the strong, or you can say concentrated alkali. Okay, means the cannizaro reaction is taking place in the presence of what? Concentrated alkali. You can take what? NaOH, or you can take what? KOH, whatever you want to. Then what will happen? The 2 molecule of aldehyde, that is without having the alpha hydrogen, they will give you what? Primary alcohol as well as the carboxylic acid. Here it is a salt of the carboxylic acid, you can write. Okay. Salt of carboxylic acid. Why? Because already we are using the sodium salt in sodium hydroxide, and potassium is also the salt in potassium hydroxide. So that is why it is giving the salt of the carboxylic acid. Now students, you can easily, you can easily identify that primary alcohol means, in general, the basic of organic chemistry, if you see the general organic conversions, aldehyde, it will get reduced into the primary alcohol. Okay. And the aldehyde will get oxidized into what? Carboxylic acids. This is the general organic conversion. This is the reduced product and this is the oxidized product. Correct? Now, let us see the reaction, students, and then followed by the mechanism. Hope you have understood the disproportion, why we are calling it disproportion, what is the meaning of disproportion reaction. Okay, what is the substrate we are using in cannizaro reaction? That is the same molecule of aldehyde, means we have to take two molecules of aldehyde that may be same or that may be different. If you are using the two different aldehyde that is not having the alpha hydrogen, it is cross cannizaro, right? And if we are using the same molecule of aldehyde, it is said to be the cannizaro reaction. Now let us see first, if I am giving a general reaction, for example, I am taking here HCHO, right? HCHO. I am taking again one more molecule of it, HCHO. Reaction is taking place in the presence of what? Already I said you, that is the concentrated NaOH. Suppose I am taking NaOH as the alkali, right? Now here we have taken the concentrated form. This is what? This is the formaldehyde. We have taken 2 moles of formaldehyde. Now, if you have taken 2 moles of formaldehyde, what will happen? It is a base induced or base catalyzed. Okay. Now, in which the 2 molecules of aldehyde without having alpha hydrogen, it does not contain any alpha hydrogen. This also doesn't contain any alpha hydrogen. It will give you what? Primary alcohol as well as the acid. Means one of the molecule will get oxidized and the other molecule that will get reduced. Okay. Means the product will be, I can write like this, plus CH3OH. Now this is what? This is the, you can say, salt of carboxylic acid. Salt of carboxylic acid. Or you can write the name of it, that is the sodium formate. Why it is formate? Because it is been derived, this sodium salt is been derived from the formic acid, right? Now, and this is CH3OH, this is known as what? Methyl alcohol, which you commonly better known as what? Methanol, right? Now, this is the oxidized product, students, and this is the reduced product. Means the reduction of the aldehyde will give you primary alcohol, and the oxidation of the formaldehyde will give you what? Formic acid. And we are using this sodium NaOH. So this is the sodium salt of the carboxylic acid. Hope you have understood the reaction, students, right? Now let us see the mechanism of it, so that you can come to know how both the products are being formed. Okay. Now, let us see this. It's quite very interesting, students. Just concentrate on the board. Okay, you will easily understand this. Now, let us take the same example, because already we have written the product. So that product we will see how it has been formed during the mechanism of reaction. Okay, step by step. We have taken what? H, right? We have taken 2 moles of it. Okay, but right now for the mechanism of it, I am using what? 1 mole only first. Okay, just I am writing here mechanism. HCH, right? Now, what it will happen? What will happen here? NaOH, we are using NaOH, right? You know how NaOH will dissociate? It will dissociate into Na plus OH minus. Already you know that this is a base induced reaction. So what we will use? Na plus or OH minus? Definitely we will use what? OH minus, right? Because this is base catalyzed. So here we will react with the OH minus. What this OH minus will do? This bond here, it will move up. Why? Because oxygen is more electronegative. It will pull the electron density from this carbon. And this OH minus will attack the carbon. Why carbon it is attacking here, students? Because when this bond is being shifted towards oxygen, oxygen will get the negative charge and this carbon will get the positive. Already students, in the previous video lectures many times I have told you, in organic chemistry, plus always go for the minus and minus always go for the plus. Means electrophile will always make a bond with the nucleophile and vice versa. Okay, so here it will be, so what will be the intermediate that will be formed? Here it will be O minus, right? Here it will be H and here it will be OH. This OH is been bonded with this carbon. Correct? Now, after that, we have 2 moles of formaldehyde, right? Now, this will react with another molecule of what? Formaldehyde. O minus, OH and here H. It will react with a fresh molecule of formaldehyde. Right? Now, when it is reacting with a fresh molecule, what will happen? Just see here. In this negative charge will come down on this. It will fall down. Where? To the carbon and the oxygen single bond. Right? When it is coming down, the negative charge. So student, negative charge means also, for your understanding, this is also containing 2 electrons. And you know, for making one bond, we need what? 2 electrons. Clear? So when this negative charge will come down, it will form a bond with it. So previously, without coming of the negative charge, we have a single bond. When negative charge will come down, there will be a formation of a double bond. Now when there will be a formation of a double bond, what will happen? There will be a hydride shift. There will be a what? Hydride shift. From where? This hydrogen, it will move out. It will go and attack on this carbon. Why it will attack on this carbon? Because already there is an oxygen. When it attacks on carbon, this will move up. As you have seen here. In the same way, it will move up, and this H in the form of H minus. Hydride, students, hydride means H minus. This is hydride. And how this H minus has been formed? The main question is this. How it has been formed? By taking both the electrons. Means by taking the pair of electrons, you can say. This bond contains 2 electrons. Now when this hydrogen is moving out in the form of what? Hydride ion, it will take both the electrons. Means 1 electron of hydrogen and 1 electron of this carbon. Both the electrons will be taken by the hydrogen and it will move out in the form of what? H minus. And where it is going? It is going and attacking on this carbon. Why? Because when it will attack on this carbon, this bond automatically it will move up. Why? Because this is more electronegative. It will develop a negative charge. And here it will be a development of what? Positive charge. And I told you, minus always go for the plus and plus will go for the minus. Clear? So I can have the structure like this. Double bond. See, this has shifted down. So there will be a formation of a double bond. Here it will be what? I can write here OH. I am writing like this. Why I am writing like this, I will let you know. That OH, I am just keeping a bond with it. Okay. Plus, here it will be HCO minus. O minus. Here it will be H. And now, this hydride ion has gone to this carbon. Now, when it is reaching this carbon, it will form a bond with this hydrogen. So, this will be again one hydrogen. Clear? I hope you have understood till here. Now, in the next step, what will happen? In the next step, there will be a what? Proton exchange. Proton, you know, proton means H plus. Hydride means H minus. Always remember the difference between the two, students, because if you are not understanding the difference, the charge matters. The H plus and H minus. When you have to remove H minus and when you have to remove the H plus, that matters a lot. Okay. So here there will be a proton exchange, you can say, or the proton transfer. What will happen? This proton will move and attack on where? This will go and it will attack this to this oxygen. Okay. this hydrogen in the form of what? H plus. It will go and attack where? This side. Okay. Now when it is going and attacking on this, because this is going out in the form of a plus, and where is a negative? This is an O minus. Right? So it will form a bond. So here we will left with what? And I told you students, whenever a particular species is going out in the form of a positive charge, it will leave behind negative, and vice versa. Means if it is going out in the form of a negative, it will leave behind positive. Always remember, these are the basic rules for the organic chemistry, for writing any reactions. So here it will be H, C, double bond O. Here it is O. Now from here this bond has been broken, and this H is moving out by taking only its own electron, and it is going in the form of H plus. Where it is going? It is going to this oxygen, O minus. Okay. So now it will be minus over here. We can write minus because this is moving out in the form of a positive. So it will leave behind negative. Okay. Plus, here it will be H, C, OH, H, H. Now I think you are just about to make the two products. First is what? CH3OH. That is the methanol. Now in the final reaction, what will happen? In the final reaction, this is O minus. Okay. We have what? We have Na plus. From where we are getting this Na plus? We will get the Na plus from this NaOH. So else you can write NaOH. And from there you have taken what? Na plus. Where this Na plus will go? It will go and attack on this oxygen. Why? Because this oxygen is having the negative charge. Negative always go for the positive. Positive will go for the negative. So that's why the final product will be HCOONA plus HC. Now, these are the two products. This is what? This is the sodium formate, and this is what? This is the methyl alcohol. Okay, here you can write also sodium salt of carboxylic acid, so that you don't have a confusion that what is this product has been formed. Salt of the carboxylic acid. So which salt? Already you have used this sodium, NaOH you have taken, so your product will be what? Sodium salt of the carboxylic acid. If you are using KOH here, then it would be what? Potassium salt of the carboxylic acid. Okay. So I hope you have understood this, students. Once again, I am just summarizing it for you. In the first step, this OH minus, from where we got this OH minus? From NaOH. Dissociation of this NaOH. We have OH minus. This OH minus is attacking on this carbon. This bond will shift towards oxygen. This is basically the electromeric effect. If you have studied, students, the electromeric effect, you have seen this shifting of breaking of this double bond towards the electronegative atom. Okay. So this is shifting on this oxygen, means the electron density is being shifted towards the oxygen. Oxygen will develop a negative charge, and this OH minus will form a bond with this carbon, because while shifting this bond to the oxygen, carbon will get the positive, and this OH minus can easily attack on this carbon. Okay, this you will get the intermediate. In the next step, this intermediate is reacting with a fresh molecule of aldehyde, that is a formaldehyde. Already in the reaction you have seen that you have taken the 2 moles of it, right? We have used in the first mole over here. Now the fresh molecule of this formaldehyde has been reacting with this intermediate. When it is there will be a hydride transfer, hydride shift. Now the hydride is shifting towards this, attacking on this carbon atom. Okay, hydride means H minus. I have written over here, 2 electrons have been taken, so H minus, it is attacking on this carbon, and this carbon will be positive charge. You know how it will be? By breaking of this bond on oxygen. Oxygen will get the negative, carbon will get the positive, as you are seeing over here, right? Now, when you are left with this, now here what will happen? This H this H is breaking in the form of what? Proton. There will be a transfer of proton transfer. Proton transfer, proton means H plus, right? H plus is attacking on O minus. When it is attacking on O minus, then oxygen will get the negative because it is detaching itself. Hydrogen is detaching in the form of what? Positive. It will leave behind negative. Now in this step, what will happen? This is the methanol already we have formed. Now this one already it is having a negative charge, and we have what? Sodium. We have used this OH, but we have Na. Okay, so this sodium ion from NaOH, it will react, it will attack on this O minus to form the sodium formate, that is the sodium salt of the carboxylic acid. Okay, and this is the methyl alcohol. So I hope students you have understood this Cannizaro reaction, what actually the Cannizaro reaction is and what is the mechanism of it. This is very, very important, students, and it is very highly probability that these type of questions, the Cannizaro reaction and all these things, they will come in the exams. Okay, so one question I am just giving you, you can solve it by yourself and you can write it down. If you are not unable to solve it, you can write down in the comment section. Then I will make one video for that. I hope if you have understood this, you can make that also, because the same mechanism will be followed. Only the substrate I am changing it. Okay. So I am just writing one question for you, and you have to solve it. Means it's just a practice for you. Try to solve it. You have to write the product over here. Okay, I'm writing here product, complete the reaction, and write the mechanism of it. So students, if you have understood this Cannizaro reaction, you will easily excuse me, if you have understood this reaction, Cannizaro reaction, I have taken the example of formaldehyde because it does not contain alpha hydrogen. In the same way, you can choose this also, benzaldehyde, because this benzaldehyde also doesn't contain the alpha hydrogen. Okay, so this reaction in the presence of KOH. Okay, I have just changed the base. Sorry. So I have changed the base here, concentrated KOH. You have to write the product and you have to write the mechanism of it. Okay, in case of any doubt, students, you can write there in the comment section. I hope you have understood this. So in the next video lecture, I will come with a new topic, new name reaction. Okay, new topic I will come of organic chemistry. Till then, thank you.